If it comes after the word probability, it affects only the top, right? So here we have a politician. We're going to redo this one. A politician is about to give a campaign speech and is holding a stack of 8 cue cards. So that's 8 total. We agree? I don't even want to know. That's 8 total, yes? So that's the maximum I have to choose from. That doesn't mean I'm actually picking 8 cue cards. Then it says, of which the first 3 are important. Now the key thing to this is, if you have 3 blanks on the top, you will have 3 blanks in the denominator. If you choose 3 on the top, you're going to choose 3 in the denominator. That does not change, right? P3, you'll have P3 in the bottom. Like, that doesn't change. We're going to still choose the same amount. So I know I'm picking 3 that are the most important. So I'm going to have 1, 2, 3 blanks, and then I have 1, 2, 3. I will never have 3 blanks on the top and 8 on the bottom. That will never happen in probability. If you're doing that, you will for sure be wrong. Okay? So if I have 3 blanks, I have 3 blanks. Yes? All right. So here it says, just before the speech, he drops all of the cards and picks them up in random order. Now, what is the probability? What it means when I say what is the probability, I'm going to have a stack. I'm going to have a numerator and a denominator. Yes? After the word probability only affects the top, though, the numerator. So it says, what is the probability that the cards 1, 2, and 3 are still in order? So I need this to be number 1, number 2, and number 3. So how many number 1s are there? 1. Number 2s? Number 3s? Make sure you have the multiplication dots. So that's after the word probability. Then I go to the denominator and I say, total no restrictions. Yes? So how many cards do I have for this first blank? 8, then 7, then 6, because I'm leaving 1 card here, right? And then I get 1 over 576. Okay, we're going to look at number 2. Number 2 says, a gardener has 11 identical looking tulips. They're identical looking. So I cannot tell them apart, right? Yeah. It's not. I don't know. What's 8, 7, 6? All right. Here we have a gardener has 11 identical looking tulip bulbs, of which 6 will produce yellow tulips and 5 will produce will become pink. So 6 will be yellow, 5 will be pink. She randomly selects and plants 6 of them and then gives the rest away. When the flowers start to bloom, what is the probability that all of them are yellow? Does this say anything about planting them in a row so you can see them? Anything like that? Are we ordering these? Does it say I'm arranging them? Anything like that? No, so if you're going with blanks, you're telling it has order, right? So if you do 6 blanks, we're in trouble, because then I'm ordering it. And does it need to be ordered? No. Now that's another thing. We're bringing back our brains from pros and cons. If I choose a girl from girls, or boys from boys, or clubs from clubs, or spades from spades, or drivers from drivers, or irons from irons, or yellow from yellow, what do I have to use? Nope. Yellow from yellow, what do I have to use? A C every single time. Because order doesn't matter, right? If I'm picking yellow from yellow, I use a C. So how do I guarantee I need to choose 6 from how many yellows? This is probability of them all yellow. This affects the top. How many yellows are there? 6. So I do 6, choose 6 over. The bottom is total no restrictions. I'm still choosing 6. And if I have a C in the numerator, I have a C in the denominator. That doesn't change either. But how many am I choosing from now?
10.
There's no 10 anywhere in this question.
Oh, no.
11. So 11, C6. So it's going to be 1 over 462. So here I have a test consists of 7 true, false questions. So there's 7 total. A student who forgot to study guesses randomly on every question. Does order matter on questions on a test? Yeah, like an answer key. Order would matter. If order matters, I put blanks, right? Which you did do. So questions on a test. 1, 2, 3, 4, 5, 6, 7. Then I have my denominator. If I have 7 blanks in my numerator, how many do I have in my denominator? 7. 1, 2, 3, 4, 5, 6, 7. because it says there's 7. Now here it says, what is the probability that the first 4 are correct? So probability, first 4 correct. I still have 7 though, right? So if the first 4 are correct, that means this one's correct. How many options? 1. It's whatever it is. What about the second one? What about the third? What about the fourth? What do I do with the last ones? 2, 2, 2, because it's true or false. If it was A, B, C, D, then I would have 4, 4, 4, 4, right? The bottom is total no restrictions. So how many options do I have on each blank? 2, because it's true or false. No saying which one it is. So had you done it with just the 4, you would have lucked out, because the 2's will just cancel off, right? So you get 1 out of 16.
You get the same answer.
So I just said, the 2's cancel. You lucked out. It's 2, that one, and that one cancel. All right. A meeting takes place between a diplomat and 17 government officials. So we have a diplomat. It's very socially. These questions. However, 10 of the officials are spies. So I'm going to write that over here. 10 spies, which means what? Not specific spies. What does that mean? How many are not spies?
7.
Okay. So here it says, if the diplomat gives secret information to 8 of the attendees, what is the probability that the diplomat gave secret information to exactly 5 spies? Am I lining these spies up? Am I giving them jobs? No. So what are these? These are C's. And once again, I'm going to choose spies from spies and not spies from not spies. Right? So I need exactly 5 spies. So this is after the word probability, so it affects only the top. How can I guarantee choosing 5 spies? 10, C5, and I still need what?
3 not spies.
Yeah, I need 3 not spies because I need 8 attendees. So I go 3 not spies, so 7C3. Now the bottom is total no restrictions. How many people do I have left to choose? I mean, how many government officials do I have to choose from? 17. And I'm choosing how many? 8. Practice typing it in. So if they want it as a fraction, that would be the answer. If they want it to the nearest hundredth, this would be the answer. If they want it to the nearest percent, this would be the answer. You have to times it by 100. So you give the answer that they asked for on the test. If they just ask for a fraction, you pick it. If they say to the nearest hundredth, they don't say hundredth percent. They say hundredth. You don't times it, right? You just go 0.36 and then 100% times by 100. Yeah. Yeah, they'll say nearest percent, or they'll say nearest hundredth. And if they don't have the word percent, you don't times it by 100. You just get the nearest. So this would be the nearest hundredth. This would be the nearest percent. That would be a fraction. Yeah. And sometimes it's just a multiple choice question. You have to make it match the answers in the multiple choice, the percent or the hundredths. Okay. So this next question, we have Sarah is carrying 6 pages of math homework and 4 pages of English homework. So 6 math, 4 English. A gust of wind blows the pages out of his hands, and I guess Sarah's a he, and he is only able to recover 7 random pages. So 7 random pages. Are we ordering them?
No.
Does random mean order? No, it means the opposite. So I know I have 10 total. I know I need 7 random. After the word probability only affects the top, so I keep reading. It says, what is the probability, now this is going to affect the top, that he recovers at least 5 pages of math? At least means cases, right? So that's 5 or 6 or 7. Can he recover 7 math pages? No, because he only has 6 to choose from, right? So he's recovering 5 math or 6 math, but what do we have to make sure we still do? How many pages is he recovering? 7. So this is 5 math and 2 English. And then this one is 6 math and 1 English, because I still need to have 7 pages in each of my cases, right? Each of those cases has to have 7 pages.
So what one? Instead of multiplying? At least.
And the word or. So I have 6C5 times 4C2, because that's an and. Or is a plus sign. Then I have 6C5 times 4C1. That would be if I just asked you for at least 5 math pages in terms and comps, right? This one has the word probability, so I have to do total, no restrictions on the bottom. So how many total do I have? How many pages total? Oh, 10. And I choose 7. Typing it in so you can practice. Okay, the next one says, given a standard deck of 52 cards, so I have 52 cards to choose from, right? No matter what. And randomly drawing 5 cards. Cards are always what? Prims or cons? Does order matter when you get cards? No, they're cons. Because the moment you get cards in your hand, what can you do with them? Rearrange them. So the order in which they're dealt to you doesn't matter. Also, another hint is if I choose kings from kings, queens from queens, spades from spades, hearts from hearts, it's a C. Every time you choose right from the same group of itself, it's a C. Every time. So here it says we're drawing 5 cards. So no matter what, on the top I have to draw 5 cards, and on the bottom I have to draw 5 cards of this statement. Determine the probability of getting exactly 1 ace. So on the top, this probability affects the top. So I get 1 ace. What else do I need here? 1 ace and 4 not aces. It's true. And that's going to affect my top, correct? How many aces are there? 4, and I choose 1, and not aces. 48, and I choose 4. All over total, no restrictions. 52C5. Yeah. So I got 0.30 if I say to the nearest hundredth. If I don't say percent, if I say to the nearest hundredth, that's what it is. The moment I am given a word, does order matter? Yes. If not, the word pool and loop mean the same thing, which they don't. So therefore, order matters. Now, remember when I said when you get a word, the first thing you do is rewrite it in stack letters so that you remember to divide by factorials? So we go A, W, E, S, O, M, E, N, E, S, S. So no matter what, I'm dividing by 3 factorial, 3 factorial. We agree? No matter what question I'm asking you, you will divide by those. Some people are like, well, when don't I ever divide? Never. So you will always divide by them. That's why I tell you to write stacked out letters first. So this one here says the word starts with a vowel and ends with a consonant. The probability. So how many letters in awesomeness? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then on the bottom of this one, I'm going to have 3 factorial, 3 factorial. Then I'm going to have total no restrictions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And on the bottom, I'm going to have 3 factorial, 3 factorial. So the bottom is no restrictions. So does the order matter at all? On the bottom? No restrictions? No. How many letters do I have for the first blank? 11, then 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. On the top, it comes after the word probability. It said the word must start with a vowel and ends with a consonant. How many vowels are in awesomeness? 5. So it has to start with a vowel, so I have 5. End in a consonant. How many? 6. How many letters have I used up? How many letters do I have left? 9. 9, 8, 7, 6, 5, 4, 3, 2, 1. So technically on the top, we have 5 times 9 factorial times 6 over 3 factorial, 3 factorial, all over 11 factorial divided by 3 factorial, 3 factorial. Could they make the 9 and the 5 join and make a 30? The 6 and the 5 join and make a 30?
No.
Yeah. It's multiplication. You can put them out of any order, right? This could be written as 30 times 9 factorial. It can be written as 30 times 9 factorial. And so that comes out as 0.27 to the nearest hundredth. Now the next one, our vowels are together. So the bottom is still the same. The bottom is still 11 factorial divided by 3 factorial, 3 factorial. Because that's the absolute maximum number of ways I could rewrite awesomeness. Yeah? Yep. The top, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3 factorial, 3 factorial still. But now I need the vowels together, and there are 5 of them, right? So I hook them together. Does it say together at the front? No, it just says together. So I get 5, 4, 3, 2, 1. And then how many do I have left? 6, 5, 4, 3, 2, 1. And I'm not done. What do I have to do? Multiply it by 7. So it was 1 more than after the hook together numbers, because there's 7 spots that could move. So you get 0.02. Printed 1 page, that's awesome. Okay. Yeah. Yeah. So in set theory was Venn diagrams, right? The great thing about probability is it's only Venn diagrams on 2 circle Venn diagrams. So it's not big ones. So say I give you this. Say I say there are 30 gotta get a marker. So there are 30 students, guys. Zip it. 30 students, 5 are in math and social. I don't know what is going on. 10 are in math, and 3 are in neither math or social. Okay. So, if I just state that, I can ask any questions I want, right, about this? So, where do I have to start? In the middle, in math and social, which is 5. Why I wrote 10, yet to figure out. 5. Okay. Then it says 10 are in math, so I just go put 10 in that spot? What do I put?
5.
5. Because math doesn't mean math only, it means math, right? So it's a whole math circle. Then I could put 3 on the outside. Then how do I find the people in social only? Yeah?
The numbers you have in there and then subtract out from the total.
Yeah. So I have 13 there, subtract it from the total, and I get 17. Right? So now, I can ask anything. I can say, how many are in social only? What would you tell me? 17. How many are math only? How many are in social?
22.
22. Right? Now, what if I ask you for the probability of that? What do you do with them? You divide by the total. What's the total? 30. It's not rocket science. I would go social only, 17 out of 30. Social, 22 out of 30. Math only, 5 out of 30. That's it. That's all. Nothing crazy, right? That's it. You just have to put it out of the total, and the total is nicely given to you. Not like perms and comps where you actually have to find the total, which is awful, right? This is given to you. So there's 2 types of Venn diagrams. Do you see this? There's plain old Venn diagrams from set theory, which is what this one is. So if I ask you for the probability of math only, you would have to do 5 out of 30, which is 1 out of 6. Do you agree? Yes? So there's Venn diagrams that are normal probability or normal set theory, and then there's something called probability Venn diagrams. So instead of them giving you 5 kids in math, they give you the probability of the kids in math. Now, you can flip to the very back of the booklet I gave you. We're going to write this on the back. So if I give you a probability Venn diagram, probability Venn diagrams either add to 1. This is if they're decimal probabilities. Or what if they're percent probabilities? What do you think they add up to? 100. Add to 100% if they are percentages. Okay? We agree? So if I use that same style of question, but I now give it in probabilities. So I say 10% of kids are in math and social. %20 are in neither math or social. And then I say 50% are in math. I actually don't have to give you the total. Why? What should it total to? 100. It should total to 100. Do we agree? Yes? So let's try this one out. we have math, social. 10% are in math and social, so I go 10, and I show the percent symbol. 20% are in neither. 50% are in math, so what percent are in math only?
40.
What would social be then? Social only would be 30. Yeah. So if I ask for the probability that they're in social, what would it be? 40%. Do I have to do any dividing if it's a probability Venn diagram? No, the answers are there. Right? Now, if it's decimal probabilities, I would just have to actually subtract it. So, I want you guys to flip to the last page. Flip to the very last page. I want you guys to do a Venn diagram for example 7. Go. Venn diagram for example 7. It's not a probability one. So you know, it's on the last page, it's this one. Talking about headache and backache relief. So, Tom and Andrew were asked to solve the following problems. 200 people with, and honestly, most people are really good at these questions if they read the word probability. You're usually really good at actually completely filling in the Venn diagrams. Most people are really good with that. They don't read probability and they don't divide by the total. That's really what happens here. These ones should be the gimme questions. You guys are really good at these. 200 people with neurology symptoms, which include headache and backaches, participated in a study to evaluate a pain relief medication. All the people took the medicine and their results were shown below. So there's 200 total. So we go down here and we do our Venn diagram. There's 36 in the middle, 126 experienced backache relief. So this would be 90. And then this one, 60 experienced headache relief. So how many would be in just headache only? 24. How many are on the outside? 50. Now we should be able to answer any questions that's given to us, right? So here, it said, what is the probability that a person who takes the drug experiences relief from at least 2 symptoms? That's 2 or more, correct? Which numbers would we add together for at least, or just even take? In this case, there's 2 circles. The 36. It says at least 2 symptoms, right? The H and the B by themselves is only 1 symptom, correct? So it's going to be 36 out of
Wait, does it say one of the 2 symptoms?
200. Oh, at least 1. I said it. It's going to be 150 divided by 200. Is that what you did? That's what it should be. 150 divided by 200, at least 1. Yeah, I read that as 2 for some unknown reason. So that will be, cancel 3 out of 4. Or 0.75. Neither of the symptoms. 50 out of 200. Which is 1 out of 4. Or 0.25. Are these questions crazy, the ones that I'm giving you right now? No, those ones are feasible, right? They don't sound like, compared to perms and comms, probability, this is like a cakewalk, right? Tom decided to solve the problem using a probability formula. Complete his work below. So probability of heads was 6 out of 200. And then probability of B would be 60. Oh my gosh. B would be what? 126 out of 100? Or 200, sorry. Guys, what if I asked you for the probability of headache relief only? What would it be? Headache relief only. 24 out of 200. Backache relief only. 90 out of 200. Nothing crazy, right? So I'm going to get you to work on these questions. This is half of the mutually exclusive lesson. The other half is using like cards and stuff like that, so it's a bit different, but most people really like this one, so I thought I'd hit you up with it after the horrific terms and cons one. That's hard. Not gonna lie. So the questions will be out of your blue book again, out of the workbook. So it's page 145, numbers 9 to 12. Get working.